All right, let's just look at the diagram to make sure we got it correctly. Here's Houston with their antenna. They're transmitting directly to the moon, we're going to say. All right. The red indicates transmitting up to the moon, 232,000 miles. And remember we said, how long does it take for that to go? 1.23 seconds. So once Houston transmits, 1.23 seconds it takes before it gets to Neil Armstrong. As soon as he starts speaking, we should not hear that for another 1.23 seconds once Houston finishes at the very earliest. By the laws of physics, we cannot hear it earlier, his response, than 1.23 seconds. Because it's got to come back another 232,000 miles minimum. That's if it's going right into Houston and directly out to a person watching their television set. So here we go. Here's Joe Public watching the spectacle, Neil Armstrong on the moon. And this has been right in front of us the whole time, guys. The whole time. Let's get into the proof. All right, the first time I play this, I'm just going to let it go through and then we'll go back and explain it. This apparently, if I remember correctly, this is where just after they landed and Neil Armstrong was taking a look at the lunar module and said it looked good. I believe that's what this is. So let's go ahead and take a listen. Notice that is Houston talking first. He says Apollo 11 Houston or whatever. Here we go.
Apollo 11, this is Houston. Go ahead.
LEM looks to be in pretty fine shape. About all we can see from here.
Okay.
There was another one I could have picked up. We're going to do two here, just two. You're going to pick up dozens of these, dozens. Now, most of the time they do it right, but they slip up. Now, let's go back again. And remember, the first part is Houston speaking, this part right here. This is something we should hear immediately. It should be a 1.23 second delay before they even hear. When he's finished speaking here, it should still be 1.23 seconds before they even hear it up there. And then another 1.23 seconds before we get it back. Correct? But we're just going to count the 1.23 seconds. The bottom one is the time from when Houston started talking. The top one is when this starts out at 0.1 or when the counter starts, which is right here actually, because I took it to where Houston stopped speaking. Can you see that there? Here's the very last moment of Houston speaking, and I've lined that up right there, okay? In fact, I'm just going to play that part of it. This is so important.
Apollo 11, this is Houston. Go ahead.
All right. 2.9 seconds was the entire Houston thing. Now it should be 1.23 seconds before, again, Neil Armstrong hears it, and then another 1.23 before we get it back. And that's 1.23 seconds before we get back the beginning of what he's saying, not the whole message. So, let's play it again at regular speed. Again, go back here if you want. Check it at slow speed. There's nothing wrong with the timers. Check it out. Here we go.
Apollo 11, this is Houston. Go ahead.
Okay. He starts speaking. Can you see down here? Right here. You know what I'm going to do? Let me edit the audio again. Turn it up in case you can't hear it. And again, right here is where he begins talking. Here's the 0 point where Houston ended. Here's where we hear him respond. 0.8, not even 1 second. Not even 1 second. One more, guys, one more. Now I've really blown this up so you can see this better. So let's play it.
Equalization, over.
Yeah, wait.
All right. He responds in 0.6 seconds. Less than half the time. The speed of light would have to be double. A little bit more than double what it is. Houston ends. Either way, I'm giving the benefit of that all the way. Let's just say we wait to the end of the beep. It should be 1.23 seconds before he hears it on the moon, and then another 1.23 seconds before we hear his response, if he started immediately.
Civilization, over.
Yeah, we think it's...
Okay. 0.3 seconds. So we won't do that. We'll give him the benefit of the doubt. What if I go there, huh? It's 0.9 seconds from the very last breath sound that Houston make, giving him every single thing.
Civilization, over.
Yeah, we think it's within normal.
0.9. Impossible. Absolutely 100% impossible. No way. There is no proof better than this. You can't beat the speed of light with sound waves traveling through space, giving them every single thing you can give them. No wires to go through, no delay going from some NBC headquarters out to your television and different things like that, retransmission. No delay. The space shuttle, they show 3 seconds or whatever it was delay, 3 to 4 seconds. And here, one way from the moon, they're telling us 0.7, 0.8. Actually, what it really is, at best, is 0.6 seconds. How can sound travel 232,000 miles in 0.6 seconds when it takes at the speed of light 1.23 seconds? Case closed.